Hello, and welcome to our first class for the AMC 12. Something we'll be talking about today is techniques for to solve series. So, just some review. For an arithmetic series is one where each of the terms are equidistant from each other. The formula for an arithmetic series, let's just call it A, is to take the average term, which is the largest term, let's just call it. If we order the terms from smallest to largest, then the largest term would be the one at the right, A1, and the smallest term will be A1. This is, what we do is we divide this by 2. That will give us the average term. And we multiply by the number of terms there are. Let's just call this n. Alright. So, the formula for a geometric series S, which is just equal to, let's just call it A plus AR plus AR squared, AR to the n minus 1, since there's n terms. The formula for solving this is to multiply and shift. That will help cancel out terms. So let's just multiply. Let's create another series by multiplying the original one by r. So this will be AR plus AR squared all the way up to AR to the n. Subtracting S from SR, if we take S and subtract SR, we will end up with A minus AR to the n. And to find S, we can just use the distributive property to divide both sides by 1 minus r, and we'll end up with A times 1 minus r to the n over 1 minus r. I'm going to assume that you know what infinite series are. So for infinite series, this will end. This factor will end up going to 0. Will end up going to 1, because r ends up going to. If it's an infinite series, then r will end up going to 0, and the 1 will just kind of cancel. The 1 will kind of just cancel out. All right, let's do a couple examples using these formulas. I'm not all right. So I'm just going to leave the geometric series formula up here, and I'll try to cut an example for each of these to see if you are convinced that these work. Alright, so for the arithmetic series, let's try to find the sum 8 plus 5 plus 2 plus all the way going down to negative 10. These each have, I know this is arithmetic because each of these have a difference of 3, and the difference between the first and last term is 18, which is a multiple of 3. Alright, so let's use our formula. Our least term, negative 10 plus 8, take the average of it, times n. So to find the number of terms, we know that the difference is 18, and the difference between each term is 3, and the difference between the largest and smallest term is 18. So 18 divided by 3 plus 1 will end up being 7. There are 7 terms in this series. Let's just count. 8, 5, 2, that's 3 so far, negative 1, -4, -7, and -10. That's 7. Right, so n becomes 7 in this. After simplifying, we will end up with -7 as the solution to this series. Okay. So let's do an example with the geometric formula. Let's say I want to find the sum 2 minus 2/3 plus 2/9 minus 2 over 27 plus 2 over 81. I can see that the ratio from each term r is equal to -1/3, and the initial term is equal to 2. After plugging in these constraints, I will end up, and n is equal to 5, since there's 5 terms. After plugging in these constraints, I'll end up with 2 times -4. 2 times 1 minus 1 plus 1 over 243. All this over 1 minus r, which is 4 over 3. After simplifying, this will end up becoming 122 over 81. Right. So that's it for our review of the arithmetic and geometric formula. Assuming that you've already learned about these from preparing for AMC 10. Alright. So the next thing we're going to go over is dealing with telescoping series. So a telescoping series, let's say we have some really intimidating giant function, such as I equals 1, the sum of I equals 1 to n of 1 over I times I plus 1. Doesn't look like this is a geometric or a arithmetic series. So there's actually a way to separate this using a method called partial fraction decomposition. The purpose of partial fraction decomposition is to rewrite this this term as the sum of two different ones. Let's just call it a over I plus b over I plus 1. You can separate the factors in the denominator. Alright, so how do we solve for a and b? Well, looking at this, one strategy I might think of is to multiply is to try to find a common denominator between these two and equate them. So after multiplying, I end up with AI plus A plus BI over I times I plus 1. The common denominators will cancel out. So I'll end up with A plus B times the term I equals 1. Notice that on the right hand side, the term before I is 0. So A plus B is equal to 0. And matching this term, I know that A is equal to 1. A is equal to 1. So B has to be equal to -1. Right? Something cool that happens is if we rewrite the series as 1 over I minus 1 over I plus 1, the middle terms will end up canceling out when we plug in the terms. Like, for example, let's plug in 1. We'll end up with 1 over 1 minus 1 over 2. Alright, next, let's plug in 2. We'll end up with 1 over 2 minus 1 over 3. And these terms already cancel out. If we keep going, then we'll just end up with 1 over n minus 1 over n plus 1. The 1 over n actually canceled out. Because the term before that, the n minus 1 term, is 1 over n minus 1 minus 1 over n. So simplifying this, we will end up with 1 minus 1 over n plus 1. And this is a telescoping series because all the terms in the middle seem to cancel out, and only the first couple terms and the last couple terms really matter. Okay. So that's an example of how to use use partial fraction decomposition for telescoping sums. Let's look at another method. Alright, so this is where the geometric series will come in handy. This method will involve changing a non-geometric series into a geometric one, or a series that looks non-geometric into one. So let's say we have something like the infinite sum from n equals 1 to infinity of 2n over 3 to the n plus 1. Okay, let's try to plug in the first couple terms. 2 over 9 is the first term, plus 2 plus 4 over 27 plus 6 over 81. I think you get the point. So as you can see, this is close but not quite geometric. A technique that can help turn this into a geometric series is the multiply and shift technique. So let's just call this the series S, which we want to solve for. We multiply this by 1/3. We'll end up with 2 over 27 plus 2 over... Oh, wait. Sorry. 4 over 81. Plus 6 over 243. If we subtract the second series from the first one, we'll end up with 2/3 s is equal to 2/9 plus 2 over 27 plus 2 over 81. This is actually a geometric series with a ratio of where r is equal to 1/3. The first term a is equal to 2/9, and the last term n is equal to infinity. Two-thirds s would be equal. Solving this geometric series, I'll end up with 2/3 s is equal to 2 over 9 times 1 minus r just becomes 1, since r is 1/3 to the infinite power. And then 1 minus r is 2/3. So this is, finally, this is equal to 1/3. And solving for s, I can multiply both sides by 3 and divide by 2. So s is equal to 1/2. There you go. That's all I have today for a couple of common techniques for dealing with series. I hope you enjoyed this video. Thank you for listening.